So today we are going to discuss about the glory hole mining. Glory hole. So this method of mining is applicable to hilly deposits. So these are the glory holes you are making to get the mineral. So suppose this is the hilltop deposit. The black portion is the mineral, and you have to drive an horizontal audit, and after that you will go vertical holes, the glory holes. So these glory holes will be used for transportation of the mineral. So here you are extracting the mineral by open cast mining method upwards, and the mineral is transported downwards, and it is taken through this audit. This is haulage way. This is the haulage way through which the mineral is taken out. So this is called your glory hole mining. So this kind of operation is not very common in India or elsewhere, because it involves a mine opening at the surface from which ore is removed by gravity. Here these holes are used to transport the mineral through the help of the gravity. So the mineral will flow downwards because of the gravitational pull through ridges. These holes are also called your ridges, connected to the audit haulage. This is the audit haulage, horizontal audit haulage, uh, and by tramming the ore, by tramming this ore to the surface on the haulage level. So this is the method of glory hole mining. The glory hole mining method is best suitable to mining on a hillside deposit
Excuse
and
me, sir.
irregular deposit. Yes,
Sir, please share the screen,
yes.
sir.
Screen screen तो share हुआ है. It is
Yes.
shared.
Slide.
Slide is shared. Are you not getting?
Not getting, sir.
You ask other friends whether they are able to see it or not.
We are able to see, sir.
Yes,
Nitish, you
sir.
can try joining.
Maybe you are having some network issue. Okay. So this glory hole method is the best suitable method of mining on the hillside deposits, and also it is applicable for irregular deposits. This deposit is very irregular. It is not a bedded deposit, it is irregular deposit, and uh, uh, can be cleanly mined without dilution by waste wall rock. You are not going to mine the waste material. Here only you are mining the mineral and allowing it to go downwards, flow downwards. Okay. So this is the advantage of this method, that you are not going to mine the waste materials. So and it is also applicable for narrow veins having been mined by glory holes. In these cases, the hole becomes narrow and long. The benches are mined away as work descends to the bottom of the deposit or to the haulage, so that spectacular steep side walls may result if the walls do not slough in. So this method of mining can be quite selective method of mining, and little waste rock is thrown on the surface tombs. This is a very selective method of mining. You are not going to mine the waste materials, only the minerals are taken out. So there is no need of throwing the waste materials on the surface dumps. The main problem, environmental objection to the method is difficulty in reclamation of the surface of the mined area. So only disadvantage of this method is that you cannot go for reclaiming the land. Reclamation is not possible in this method of mining. That is the only principal environmental objection you get from the environmentalists. So this is glory hole mining. So this glory hole here, it is clearly explained in this diagram. So this is the black portion is the mineral you are going to mine, and this is the vertical ridge, vertical hole through which the mineral is taken downwards to this audit haulage, and these vertical holes are also called your ore pass, through which the ore is passing downwards through gravity, and after the mineral is taken to this place, then crossing grinding is carried out in this crossing plant, and mineral is beneficiated. So this glory hole mining, uh, in the case of glory hole mining, pit is opened up in this method and developed in such a way that working faces are arranged in the form of concentric steps. Step mining. It is very cheap method of mining and loading the ore, because you are not going to mine the overburden materials, rock materials. Only mining, you are mining the deposit, the minerals. So the lignite deposits in North Bohemia is a great example of this method of mining, glory hole mining. In India, we are not practicing this method of mining, but in other countries, they are mining by glory hole method. So there is another method of mining is there, which is called your auger mining, which is called your auger mining. So this auger mining is applicable to thin deposits. If the coal seam is very thin and you cannot remove the overburden, it is this overburden material is very thick compared to the mineral or the coal deposit. Coal deposit is very thin, so you cannot go for underground mining, you cannot go for surface mining, so you have to go for auger mining. What is auger mining? So auger mining refers to a method of removing the coal, clay, phosphate minerals, oil shale from thin seams. It is applicable to thin seams exposed in deep trenches or high walls in strip mines. The deposit is thin and horizontal, uh, and it is covered by overburden materials. So the mineral is very the seam, the coal seam deposit is very thin. Therefore, you have to go for auger mining. The auger mining consists of two principal pieces of equipments. The first is a cutting head, the machine through which you are going to mine is called your auger. It has got two components. One is cutting head, and generally from 1.5 to 8 feet in diameter. The diameter of the cutting head is 1.5 to 8 feet in diameter. This may be a single auger or a double auger or a multiple auger. There may be only one auger, or it may be having two or three or four augers. The second piece of equipment is your prime mover engine. The second piece of the equipment is the prime mover or engine, which is skid mounted carriage. It is mounted by the help of a skid, providing a mounting for the engine, for the drive head, and for controlling the machine. As coal arrives at the surface, as coal arrives at the surface, it is transported via a conveyor belt or a front end loader to a waiting truck. So the auger mining, the auger is spiral so spiral type of augers. So therefore, after mining, the coal is taken by the crevices, by the uh, annular space in the auger. So auger rotates, uh, for example, uh, clockwise direction. So the material flows in the anti-clockwise direction. The material after coating flows through the auger and it is taken to the belt conveyor, where the material is loaded to the belt conveyor, or by the help of a front end loader you can also load to the trucks. So these auger mining method operations are usually very low cost, because you are not going to remove the overburden. Here also, like your glory hole mining, here also you are not going to remove the overburden. You are mining only the thin coal deposit. So therefore it is very low cost and very highly productive method of mining. But recovery ranges from 40% to 60%. You cannot go for 100% recovery, because if you take out all the coal, the overburden will fall down. So you have to leave some pillars. You have to leave some pillars to support the overburden material. So therefore, the percentage of recovery is only 40% to 60%. This method can be implemented with a relatively low capital cost. No need of any money capital necessary for auger mining. Only machine you need is the auger machine. So auger machine and belt conveyor or the payloader, front end loader and trucks. This much of equipment can give you very high production in auger method of mining. Auger method of mining. Okay, so this is the auger mining. Let us go to the other like other methods are there. So here you can see a dragline mining method. Wait. Dragline mining. So what is dragline mining? Dragline mining method. So in the dragline method of mining, you have to go for drilling, you have to go for blasting. Then after that, after drilling and blasting, the dragline itself will carry out the loading, hauling and transporting simultaneously. The dragline is a piece of heavy earth moving equipment which can load the material, which can haul the material, which can transport the material to a greater distance because of the very big boom length of the drag line. Means the overburden material will be dragged by the drag line and it will be thrown to the decolled area from where you have already mined the minerals. So the void which is created after mining can be filled up by the waste materials, by the overburden materials, by the help of a drag line. So there is for transportation of the overburden, you do not need any type of hauling equipment. You do not need any shovel for loading purpose. You do not need for transportation purpose. The drag line itself will dig the material and throw the material at a greater distance from where you have already mined out the coal. In the decolled area, the waste material can be dumped. So only thing you have to do is drilling, blasting you have to carry out. After that, the dragline will carry out three operations: loading, hauling, transporting. And after, of course, after that, the mineral will be taken to the mineral beneficiation plant, or the coal will be taken to the coal washing plant for cleaning the uh, coal. Okay, so this is the dragline working method. Dragline working method. In this dragline working method, you can see this is the dragline machine. This is the dragline machine. This is the drill machine. So the drill machine is drilling the holes, and after that the material is blasted. So this top person, white person, is the waste material, the overburden material, the rock. So after drilling and blasting is carried out, then this drag line will remove this overburden and dump in the reclaimed area from where the coal is already taken out. The overburden material, the waste material, will be mined by the help of the drag line, and the drag line's boom length is very high, so it will throw the material to the decoaled area. It will transport the material to the decoaled area from where the coal is already taken out. So this pile of rock is called your spoil pile. This is called your spoil pile, spoil material. And after the coal, this black portion is the coal is exposed. This black portion is the coal which is exposed. After the overburden is taken out, the coal is exposed, and the coal is mined by the help of a shovel and dumper. Shovel will load the coal to the dumpers, to the trucks, and these dumpers, they will carry the coal to the coal handling plant, coal washing plant. So this method of mining is called your dragline method of mining. So it is also called a strip mining, because the coal deposit is horizontal or flat deposit having zero inclination. So the coal deposit is covered by the overburden materials, and these overburden materials are to be removed and dumped in the decoaled area from where the coal is already mined out. So reclamation is carried out simultaneously in the case of a dragline mining. Okay, in the case of a dragline mining, the reclamation is carried out simultaneously. So after taking this strip of coal, then you can come to this side. Next strip you are going to mine. So this is the sequence of mining carried out with the help of a dragline machine. So what is a dragline? So the drag lines are deployed wherever there is scope for side casting, overburden above the coal seam into the decoaled area. So where you can use the drag line, the drag lines are used where there is a scope for side casting the overburden uh, uh, in the decoaled area. Means after the coal is mined, the overburden material will be dumped in the void which is created after mining. So in that case, you can go for dragline mining. And this method of mining is very cost effective technology. The dragline technology is very cost effective uh, because it will produce more mineral. It will be used for handling the overburden materials very quickly, and the cost of overburden removal is very cheap compared to shovel dumper technology, shovel dumper mining. So therefore, there are two draglines working at RG Opencast Project 1 and RG Opencast Project 3 with bucket size of 24 cubic meter. The size of the bucket, dragline bucket, is 24 cubic meter and 30.6 cubic meter respectively. Two draglines are working in synchronic collieries, 24 cubic meter dragline and 30.6 cubic meter dragline. The bucket capacity of the dragline is 24 cubic meter, and another dragline is there whose bucket capacity is 30.6 cubic meter, and both of these draglines are performing very well in that mine. So a dragline bucket consists of a large bucket. The size of the bucket is very large, which is suspended from a boom with wire ropes. The dragline bucket is suspended from a boom with wire ropes. The dragline bucket can be maneuvered, can be moved by means of a number of ropes and chains. The bucket can be moved by the help of the ropes and chains. So what is the operation of dragline? How do you operate the dragline? Operation of dragline. In a typical cycle of excavation, the bucket of the dragline is positioned above the material to be excavated. The dragline bucket is then lowered downwards and the drag rope is then drawn so that the bucket is dragged along the surface of the material. The dragline bucket is then lifted by using the hoist rope. A swing operation, you can swing the dragline up to 180 degree or 360 degree also it can be swinged. A swing operation is then performed to move the bucket to the place from where the material is to the place where you want to dump the materials. The drag rope is then released, causing the bucket to tilt and empty the material. So this is called a dumping operation. It is an independent machine. Dragline is an independent machine, not like a shovel. It is an independent machine. Shovel is dependent on the trucks. Unless trucks are there, the shovel will remain idle. Therefore, shovel is dependent on the dumpers, whereas in the case of a dragline, it is an independent machine. It works, no need of dumper is necessary if you are operating the dragline. The dragline can itself dump the material, transport the material to a greater distance. Therefore, it is an independent machine. Dragline is an independent machine, whereas shovel is a dependent machine. So a 30 cubic meter dragline can handle 40 lakh cubic meter of overburden per annum. Annually, you can remove 40 lakh cubic meter of overburden by using a 30 cubic meter dragline bucket capacity. The dragline works on the immediate overburden bench above the coal seam, and the benches from the surface to the dragline are normally handled by shovel and dumper combination. So after the overburden material is removed by the dragline, the coal which is exposed will be taken by the shovel and dumper combination. Hence, adequate capacity of shovel and dumper capacity should be provided to prevent idling of the dragline. So, in the coal mines, the dragline is used to remove the overburden material, waste material, and the shovel and dumper is used for taking out the coal deposit. So after the coal is mined, the dragline will dump the overburden materials over the decolled area. Therefore, the dragline capacity should match with the shovel dumper combination so that the dragline will not remain idle. It should not remain idle. Otherwise, if the shovel and dumper is very small machine and dragline is very big machine, then they will not be compatible to each other. Dragline has to wait till the shovel dumper mining is finished. Therefore, you should have proper capacity of the shovel dumper to cope up with the dragline capacity. So the dragline is having a very big boom length. The dragline has a very long boom with a bucket capacity ranging from 15 cubic meter to 50 cubic meter. Drag lines are also available with 50 cubic meter bucket capacity. Starting from 15 cubic meter capacity to 50 cubic meter capacity, drag lines are available. And the drag line can swing in 360 degrees. It can swing all around. The drag line can swing 360 degrees after dragging the loose material below its level. It swings normally between 90 degree to 120 degree, because if the swing angle will be more than 120 degree, who is muting means don't mute my class. Okay, so here the uh, it swings normally between 90 degree to 120 degrees. Okay, so if the swing angle is more than 120 degree, the cycle time of the drag line will increase. Therefore, the economical swing angle is 90 degree to 120 degree, and side cast the material into the decolled area. The main purpose of using the drag line is to side cast the material to the decolled area. The nomenclature of the drag line usually called as 24 by 99. What does it mean? 24 by 99. What does it mean for a drag line? 24 by 99 drag line means the 24 cubic meter is the bucket capacity and 99 meter is the boom length. Boom length is 99 meter. Bucket capacity is 24 cubic meter. So this drag line is called 24 by 99 drag line, which means 24 cubic meter of bucket capacity and 99 meter is the boom length. So the same drag line can have about 30 cubic meter of bucket capacity if the boom length of 71 meter normally taken. So the drag lines are electrically driven. These drag line machines are electrically driven with 6.6 kilovolt power with two main motors of 1750 horsepower each. So the drag lines machines are electrically operated and driven by 6.6 kilovolt power with two main motors are there, each of 1750 horsepower. These motors in turn drive the generators and the generators drive the DC motors. This way the drag line operates. Normally there are 7 DC motors are there for different operations like marching. Suppose you want to move the machine from one place to other place, that is called your marching. Second one is called dragging. Dragging the overburden material by the help of the bucket. Then hoisting the material lifting the material, and after that swinging the boom, swinging the bucket to dump the material. So for this purpose, you need 7 number of DC motors. Okay, and this is the way by which the drag line is operated. So here you can see very clearly dragline bucket. This red one is the dragline bucket. So this dragline bucket is suspended by the wear ropes. This uh, this green, by the help of this green buckles, by the help of this wear ropes, the bucket is suspended, and the green peaks, the green color peaks are the peaks through which the material will be scoped. Okay, and the drag line bucket is having several uh, uh, cables are there, chains are there, uh, uh, for the purpose of scoping the material, for the purpose of raising the material, for the purpose of dragging the material, and filling the bucket. For that purpose, you are having number of wear ropes are there, number of chains are there, so that the material can be uh, collected or dragged. So this in the bucket, in the front of the bucket, there is a arc cross section redesigned for increased strength and durability. And on the back side, shorter length leads to reduced full ton. And this lower trunnion position improves the dumping of the material, and the unique bucket design increases the payload of the bucket. And here optimized hitch position for improved digging in all applications. The material should be dug by the help of the bucket, and here there is a reverse spade lip for easier penetration, and here tapered profile reduces drag loads. So this is the configuration of a dragline bucket. It is operated by drag ropes. Ropes are there and chains are there. Okay, so this is the dragline bucket. So here in this diagram, line diagram of the drag line, this is the boom point, this is the boom point, this is the boom length. So this is the boom, this one, this is the boom, and total length is called your boom length. And from the boom point, the bucket is suspended by the hoist rope. From the boom point, the bucket is suspended by the hoist ropes, and there are, for rigging purpose, rigging cables and rigging chains are there attached to the bucket, and the operator sits here, operator's cabin. In the operator's cabin, the operator sits and operates the machine, and this is the drag rope of the bucket. So the material can be dragged by the help of this drag rope, and the material can be lifted by the help of these hoist ropes. So one hoist rope is there, one drag rope is there. Then for rigging purpose, the rigging chains are there and rigging cables are there. So this is the suspension rope. This is the suspension rope uh, for suspending the material. Uh, okay, and this is the machinery house, and revolving frame is there. Revolving frame is there, by the help of which the drag line can rotate 360 degree. This is again shown in a very uh, better manner. Line diagram of a drag line. This is the machine. This is the drag line machine, and the drag line machine is having the highest ropes. These are the highest ropes. This is the boom. This starting from this black color till the red color, the total length is called your the boom length, and these and the highest coupler is there and highest rope is there. Then dragline bucket is suspended from the boom point, and there is a drag coupler, there is a drag rope is also there for dragging the material. So the main part of the dragline machine is that it sits on the top of the bench. The dragline sits on the top of the bench, which is to be removed. So by sitting on the top of the bench, this bench will be removed or cut by the drag line machine, and after cutting, this material will be dumped in the decooled area. So this is the difference between a drag line machine and a shovel. So the drag line sits on the top of the bench which is to be removed, whereas in the case of a shovel, the shovel sits on the bottom of the bench and takes out the top bench. So this is the difference between a drag line machine and a shovel machine. So where the drag line can be applied, where you can apply the drag line, where the drag line can be used. So the drag line can be used in the gradients flatter than 1 in 6. If the flat seam is there, so if the gradient is flatter than 1 in 6, if gradient is more, the dumped overburden material will slide towards the coal face, and particularly in rainy season, the extraction of coal become very dangerous. So therefore, the drag line can be used for the gradients which are flatter than 1 in 6. It should not be inclined surface. The deposit should not be very inclined, otherwise the material will flow downwards. The coal seam should be free from geological faults and other geological disturbances. Faults, faults, dikes should not be present in the coal seam. Then only this method of mining, dragline method of mining, can be adopted. The coal deposits with larger strike length, the strike length should be more than 2 km, so that frequent shifting of the drag line from one end to another can be reduced. So the deposit strike length should be more than 2 km, so that the drag line can be operated efficiently, economically, without shifting very frequently. So the present cost of drag line is more than 100 crores. The machine cost of the dragline equipment is more than 100 crores. So that is why you have to justify your deposit, your mining economically if you are going to purchase a dragline machine, because it is very costly machine. 100 crore, more than 100 crores machine if you are going to purchase, then you should have sufficient amount of coal present in your mines, and you should have bigger deposit. You should have more coal available, life of the mine should be more, then only you can invest 100 crores of rupees for purchasing the dragline machine. And the life of the dragline is usually 1.5 lakh hours. The life of the dragline is 1.5 lakh hours it can operate. The property should be large enough. The coal deposit should be large enough, ensuring the life of 25 years or more. So if the deposit is very extensive, very big, and it will last for 25 years, and then only you can go for dragline mining. And uh, uh, if the deposit is situated at the hilltop, this method of mining is not suitable. Dragline method cannot be used for hilltop deposits. And the life of the property should be at least 15 years of life should be there. 15 years of mining and the deposit with adequate production should be there. Then only the dragline method of mining can be adopted. So in the case of another method of mining is there, which is called your in-pit crossing and conveying. In-pit crossing and conveying. What is in-pit crossing and conveying? So in the case of in-pit crossing and conveying, you have to drill the material, you have to blast the material. After that, the material is to be loaded. So after the material is loaded to the uh, after the material is loaded to the crosser, so the crosser will cross the material, and after crossing the material, it will be transported through the help of a belt conveyor system. So therefore the method is called your in-pit crossing and conveying. In the pit itself, in the mine itself, you will have a crossing plant. So after drilling blasting is done, the material will be loaded and taken to the crosser, to the crossing plant, and after the material is crossed to the required size, it will be conveyed through the help of a belt conveyor system. So the crossing plant, the crosser, will be located in the pit itself, inside the mine. Therefore it is called in-pit crossing and conveying. Why you go for in-pit crossing? What is the necessity of going for in-pit crossing? If you want to convey the materials by the help of a belt conveyor system, then you have to go for in-pit crossing. Why? Because the conveyors, the belt conveyors cannot take the boulders. So the boulders are to be crossed to the required size so that the material can be loaded to the belt conveyor system for its transportation. So then why you are going to select the conveyor system? Why don't you are using the dumper? Because dumpers are very costly transporting equipments, because they operate on the diesel oil. Diesel is very costly, and you need a number of dumpers, number of trucks, number of drivers, number of helpers, more number of drivers, more number of helpers, more number of dumpers are necessary for the transportation purpose. But and it is also very costly because of the diesel consumption. Diesel is very costly. Therefore, if you adopt the conveyor system, conveyor can be operated electrically. The conveyor system can be operated electrically, and there is no need of drivers, no need of helpers. Only it will operate by the switch button. Means by a single person, the material can be loaded, the material can be transported, and huge amount of material, continuous mode of transportation would be there. So there is no need of empty trucks coming for the loading purpose. So the hauling and transportation would be carried out by the help of the in-pit crossing and conveying system. So if you are going for conveyor, then the material size should be such that it can flow very easily on the conveyor belt. So for that purpose, you have to go for crossing the material. Boulders cannot be taken by the conveyor system. So you have to cross the material. So that is called your in-pit crossing and conveying system. So these in-pit crossers are of different types. It may be a mobile crosser, it may be a fixed crosser, it may be located at the bottom of the pit where the material will be crossed to the required size to be loaded to the belt conveyor system for effective transportation. So after the material is transported by the help of the belt conveyor system, it will go to the processing plant or the coal washing plant. So this is the flow diagram of in-pit crossing and conveying system. So what is in-pit crosser conveyor technology? In-pit crossing and conveying technology. What is this technology is called? The drilled, the drilled, perhaps in the next class we have to go uh, because time is there not there, so we'll discuss this in-pit crossing and conveying system in the next class. So today we have discussed some of the methods like glory hole mining technology, auger mining technology, dragline mining technology. Three technologies we have discussed today. One is glory hole mining. Second one was your auger mining. Third one we discussed is the dragline mining. Okay, uh, dragline mining. So next class we'll discuss about the in-pit crossing technology. In-pit crossing technology. Thank you. Have a nice day. Good luck to you. Thank you. Thank you.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Okay.
Thank you, sir.